Hi everyone, sorry, my video suddenly stopped. Let's continue. The previous one is video number 30, now video number 31. Video number 31. This is the continuation from the previous case. My video suddenly stopped, I don't know why. So let's do it. So we start from that, how to find this x, or what is this x and what is this. Okay, from the given surface z equal to fxy, you can always rewrite this in terms of function of xz. So y equal to h, let's call that function h, x and z, and you can always write this as y equal to h minus x minus z, and we give a name to this. What we already have h. Let's call this function phi. Let's call this function phi. Okay, so this h, because y we have substitute y is equal to hx. Now in this function here, our y we substitute with that h. Remember that this h, so that's why we have our h here. And for this case, this is how to transform this ds surface into the xy plane. All right, so from this, so what we have, if we put or impose the del operator to phi, that give us what? Give us negative of hx, differentiate y got 1, differentiate z, we have negative of hz. Okay, if you take the magnitude of those phi, okay, so we have square root of hx squared plus hz squared plus 1. Okay, these terms, we put it here, there. All right. Now, lesson number 1. Number 2. Number 1, we project on the. Remember that we have 3 cases. We project the surface on xy plane. I gave you a very complete example there, and then we project those surface on xz plane. I don't give example this one. The process is similar, just need to change the function, the surface here. All right. And the third case is that we project those surface on yz plane. So remember that for yz plane, we don't have a function. We don't have x, because on xy plane, on yz plane, we don't have x. So you need to substitute x in that case. Now, for that purpose, you can always write that function. The given surface, as a function of z, y, and z. So I can write this as a x equal to, let's say, some function k of y and z. Okay, the rest you can do the same process here to find what is the magnitude of del, to get to substitute the ds. All right, so for that, let's say yz, we obtain ryz by projecting the surface on the yz plane. So this is ryz. Okay, projecting the surface as on yz plane, or in other words, we look at x positive. Okay, so our integral as g xyz ds that will give you, we integrate over r yz, r yz, g, our x, we have written those function, all right, as a function of y and z. So our x is k yz, we have y, we have z. The magnitude of those phi here given as, because x, now x is 1, so we have 1 plus k y squared plus kz squared. Here dy dz, okay. Having done that, let me give you some exercise. If you have free time to do it, so evaluate as g x y z ds for g given as x plus y plus z, and our s is given as z equal to 4 minus x minus y on the first octant, on the first octant. Okay, so you can, with the same example here, let's say for A, you consider R projection on xy plane. See what happened. You can consider B R. Let's call this xy plane. So let's call this xy. Let's call this yz. If we project on yz plane, projection on yz plane, and you can consider xz projection on xz plane. Okay, you have the same surface for all of these three region on different plane. The surface is the same, so I'm expecting that you should get the same result for all these three different cases. All right, so with that, we end up this video number 30 and 31. Thank you.